আজ আমরা বেসিক সলিউশন অফ অ্যান এলপিপি লিনিয়ার প্রোগ্রামিং প্রবলেম নিয়ে আলোচনা করব। প্রথমে আমরা একটু দেখে নিই যে স্ট্যান্ডার্ড ফর্ম অফ অ্যান এলপিপি ইন ম্যাট্রিক্স ফর্ম বিষয়টা বলতে কি বোঝায়। স্ট্যান্ডার্ড form of an LPP of an linear programming problem, and that is also in the form of matrix form. And a basic linear programming problem in the standard form can be written as optimize Z. This is equals to C transpose X subject to the certain constraint. The constraint is X equals to B, vector symbol, and X vector is greater than equals to 0. That type of here optimize means either maximize or minimize. This is called the standard form of an LPP linear programming problem. Now the question is, what is A, X, B? So where C is basically the vector C1, C2, Cn. X is x1, x2, xn, n cross 1 is the matrix. The matrix is basically of order m cross n, Aij m cross n, and B is basically m tuple B1, B2 dot dot Bm. This is m cross 1. So generally একটা এলপিপি প্রবলেম আমাদের স্ট্যান্ডার্ড ফর্মে যদি লিখি সেটা এক্স্যাক্টলি এই টাইপের দেখতে হয়। আমি এই বক্স করে দিলাম। নাও there is certain question. The question is, what should be the solution of the LPP? And next we will move to the basic solution. So solution means if there is such x which satisfy the equation. Here this is Roman 1, the constraint is Roman 2, and we can consider is Roman 3. So when we are taking the LPP in the form, that LPP is basically the standard form. Now we'll move to the basic solution. How you will say the basic solution of an LPP exists or not. So next recall is basically related to the basic solution. So here the assumption is LPP in the form of standard form, linear programming problem. This will be x equals to b, and x is basically vector belongs to Rn, n tuple, and where A is basically Aij m cross n matrix, real matrix of rank, this is very very important, rank M, and M is exactly less than N. And B, this is basically B1, B2 dot dot Bm. This is M cross 1 real matrix. This belongs to Rm. Now when we'll see X equals to B, this is basically system of linear equation. So if we write all these things, A11, A12, A1n, A21, A22, A2n, AM1, AM2, AMN, multiple x1, x2, xn. This is M cross n matrix. This is n cross 1. B1, B2, Bm, M cross 1. And you will see this is a linear system of simultaneous equation. x1, a1 to x2 plus dot dot dot. a1 and xn equals to b1. a21 x1 plus a22 x2. a2n xn equals to b2. And a m1 x1 plus a m2 x2. A mn xn, this is equals to bm. So this is system of linear equation with n unknown. Now the question is, in this above system of linear equation, that means LPP, linear programming problem, what should be the number of equation? Here the number of equation is m, and number of unknown, this is basically n, and where n is strictly greater than m. And rank of the matrix, rank of A, this is equals to m. So this is our observation. Now the question is how to solve this kind of linear system of m equation and n unknown. So here actually আমরা জানি যে m equation and n unknown যদি solve করতে হয় তাহলে we need to consider the m minus n minus m variable as free variables. So here number of free variables, this will be n minus n. A system of equation can be solved if that is m equation, same number of equation as same number of unknown. But here the number of unknown is basically greater than the number of equation. So need to consider the n minus m variable as free variables. So now setting n minus variables equal to 0, Why we are setting n minus m variable 0? As the reduced system of m equation with m variables. Why m variables? Because n minus n variables are basically 0. So we have now the m equation with m variables and it has a unique solution. Why unique? Because m equation and n variable and coefficient matrix is invertible. Why it is the coefficient matrix of order m cross m is invertible? Because the rank is basically m. So has unique solution. Then the solution is obtained. The unique solution where x1 x2 dot dot xn where n minus m variables vanishes. তার মানে এই যে n টাপলের মধ্যে কোনো একটা n minus m variable must be 0. Now or in this case, next in this case the associated column vector for the remaining m variables are linearly independent or equivalently we can say the m cross m submatrix B of A formed by the associated column vectors is non-singular. Why? Since here the rank of B is basically M and it is exactly the order of B, and this implies determinant of B is non-zero. That means B is non-singular. Now these m variables which are not bound to 0 is called the basic variables. Because n minus m variables are vanishes, the remaining m variables which are not bound to 0 are called basic variables. And the n minus m variables which are equal to 0 but which are vanishes are called non-basic variables. Non-basic variables. That means when we will get the unique solution, it is in the form of n tuple. And in n tuple solution, n minus variable, we have considered 0, and the remaining m variables, that is not bound to 0. So this remaining m variables is called the basic variables, and the variables which we consider or which we set as 0, this is basically non-basic variables. Now, the matrix B corresponding to the basic variables is called the basic matrix. The matrix B corresponding to m basic variables is called basic matrix. And the columns of B, each column of B is called basic vectors. So here আমরা এটা জানলাম যে বেসিক ম্যাট্রিক্স এন্ড বেসিক ভেক্টরস বলতে আমরা কি বুঝি। পরে আমরা একটা এক্সাম্পল দেব এবং সেই এক্সাম্পল আমরা ক্লিয়ার করব যে এক্স্যাক্টলি প্রত্যেকটা যে থিওরিটিক্যাল যে কনসেপ্ট সেটা কিভাবে আসছে সেটা কমপ্লিটলি আমরা আন্ডারস্ট্যান্ড আর কমপ্লিটলি আমরা বুঝবো। Now, any basic solution to the linear programming problem x equals to b, in which all variables are non-negative, is called basic feasible solution. Basic feasible solution, BFS. And next, a basic solution to the system x equals to b, this is linear system, x equals to b, in which at least one basic variable vanishes, is called degenerate basic solution. Degenerate basic solution. On the other hand, or otherwise, if no basic variable vanishes, no basic variables vanishes, then the basic solution is called a non-degenerate basic solution. A non-degenerate basic solution.